Alright, geometry, this is Unit 11, Homework 7. This is Mr. Tanis. We're doing volume today. Volume of prisms. Rectangular prisms. Rectangular prisms mean they go straight up. Alright, so you basically have a right angle between the base and the side that goes straight up. Alright, oblique means it's leaning, rectangular means it goes straight up. And the volume formula for all of these is the same. It's the area of the base times the height. Alright, the only thing that's going to change now is what the base is made up of. So we'll start with a rectangle for a base, a rectangular prism. Alright, so rectangular prism volume equals area of the base times the height, but the base is length times width. So if you plug in length times width for the base, you get length times width times height. So you just multiply those values. And they're interchangeable because obviously, multiplication is commutative. So sometimes I don't know what's called length and the width. It doesn't matter. Switch them up. 9 times 17 times 24 gives you 3,672, and that's cubic centimeters because we're talking about volume. Alright, so if we were to try one, it's the same thing. Volume equals area of the base times the height, and the base is length times width times the height. And obviously you don't have to write this first step. I write that helps me, but just because I use it for the volume of every prism. But you can jump right to length times width times height for a rectangular prism. And the length then, let's say, is 12. The width, let's say, is 8. And the height, let's say, is 39. And that gives us, if you multiply those numbers, 3,744 cubic feet. All right, let's try number 4. All right, number 4 for prisms, once again, it's still volume equals area of the base times the height. Now the area of the base is going to be a triangle, so it's going to be 1/2 small b for the length of the base side times small height times capital. I'll use capital H now for the height of the actual prism, because it is hard to keep this straight. But the area of the base of the triangle is 1/2 base times height, and then the actual height of the prism then is in this case going to be 5. So let's go ahead and do this one. The base right here is 12 because you can see this is 12, so this side is also 12 down here. So the base of the triangle itself, lowercase b, is 12. We're going to do 1/2 base times height for this small triangle on the bottom, and the base of that is 12. The height of that triangle is 7.3, and then the height of the total prism then is 5. Alright, so that's just a visual thing. Hopefully you can see that, but we're trying to find the area of this small base on the bottom, which I've shaded, and then once we find that, we multiply it by the height. Alright, and that gives us 219 cubic feet. Okay, let's try another one. This one's not a triangular prism. This is a trapezoidal prism. Alright, so we've got a trapezoid for the base, and the base isn't always on the bottom, right? The base can be anywhere. It's the two sides that are the same in parallel as we learned. So this is the base right here, this trapezoid here, or the other trapezoid here on the other side, on the right side. But I'm going to use this trapezoid on the left side, and I'm going to do the volume is area of the base times the height. Now that base is the trapezoid, so 1/2 height times base 1 plus base 2 was our formula, and I'll use capital H now for the height of the prism itself, which is going to be 25 here. So I can keep that separate from height of the trapezoid. So let's go ahead and do this. The height of the trapezoid is 17.9, and the two bases then of this trapezoid are going to be these two sides, 36 and 14. So 36 plus 14, and the height of the actual prism itself is going to be this height, 25. Alright, so if we multiply those numbers together, we get 11,187.5 cubic meters. Okay, let's do 7 actually, because we just did a trapezoid. So here's another trapezoidal prism. Let's do a triangular prism here. The bases are actually the triangles here. That are the two the two congruent triangles on each side of this are the bases. All right. So once again, volume is area of the base times the height. The area of the base is now a triangle, 1/2 small b times height. So I'll make it capital H for the height of the figure, which is going to be 21. All right. Now the triangle. Let's see. This is a right triangle. I've got the height of it, but I don't have the base. I do have the hypotenuse though. This is 32.5. So if I have a right triangle with two side lengths, I can find the other one with the Pythagorean theorem. So let me call this the small b, and I'll do small b squared plus 28 squared equals the hypotenuse squared. And you guys can solve that pretty easily. Gives you about 16.5. Alright, so the base of the triangle is 16.5. And then the height of the triangle itself is 28. And now I do the height of the actual figure, which is 31. Alright, and that should give me 7,161 cubic kilometers. Okay, let's jump to cylinders. Cylinders, it's the same thing. It's still like a prism where you have area of the base times the height is your formula, but now the area of the base is a circle, so you're gonna have pi r squared times the height for your formula right here. All right, so the first one here, we've got pi times the radius is 18 and the height is 15. Pretty straightforward. We can leave pi in our answer and we get 4,860 pi if you want an exact answer, or if you want an approximate answer, that's 15,268.14 cubic inches rounded to the nearest hundredth. Alright, so these are pretty straightforward. I'll do this other one really quickly then too. Area of the base times the height. Area of the base is pi r squared, not 1/2 pi r squared, pi r squared. And then the height is the height of the figure, height of the cylinder. So area of the base times the height. The radius in this one is 5.5 or 11/2, and the height of this one's 21. Alright, it's pretty straightforward. 1,995.7 cubic meters. Alright, let's do some harder ones, I guess, the application one. And you're going to do a lot more of these type of problems when you get to calculus, but especially these rate ones. But let's do 11 first. We have a cylinder with a 2 centimeter diameter. It's been drilled through this triangular prism, and we want to find the volume of the prism. So we're going to do the volume of the triangular prism, and we're going to subtract the volume of the cylinder. Alright, the prism is area of the base times the height. So area of the base times the height. The base is the triangle, so that's 1/2. I'll do this as the base up here, because I've got a right triangle with 5 and 5, so 1/2 5 times 5 is the base and the height. And then that's the area of the base times the height of 14. And we need to subtract the volume of the cylinder. This thing has a 2 centimeter diameter. The volume of a cylinder is pi r squared times the height. So it's pi, and the radius then is going to be 1 centimeter. And the height of the cylinder is 14. Alright, so hopefully that's pretty straightforward. That gives us 131.02 cubic centimeters. Okay, then the last problem, we have a rate problem, which is pretty much what calculus is all about, rates. So we have 80, they give us a rate of volume per hour. Alright, so I'm going to write that rate down because that's really important. 80 cubic feet per 1 hour. Alright, so if I'm going to do anything with this rate to actually find how many hours it's going to take in the bottom here, I need to get volume, because that's what the rate we have. We have a rate of volume per time. So if I'm asking a question about time, I need volume. Alright, those are the two quantities that we're interacting with here. So volume of this thing is equal to area of the base times the height, which is pi r squared times the height, which is pi, and the radius is 1/2 of 27. 13.5 times the height of 4.5. Alright, that gives us a volume of 2,290.22, and that's cubic feet. Alright, now here's our, I guess you can call it a unit conversion. Alright, it's our conversion between volume and time, or time and volume, depending on how we flip this fraction. We're asked a question about how much time, so what we want is to get the volume to cancel. We're going to multiply by hours over cubic feet. So we're going to flip our rate here that we were given, or our unit conversion, and the cubic feet will cancel, and it will get our answer in hours. So basically we just need to divide our volume by 80, and that gives us our answer for how long it's going to take, which is 28.63 hours. All right, I hope this helps. I hope you guys do well on the homework. Once again, let us know if you have any questions, and I hope you have a fantastic